Welcome to my channel Sparkle Mind. Students, இந்த வீடியோவில் CBSE plus 2 23-24க்கான examination important questions in application of integration, that is in A.O.I important questions and solutions பார்க்கலாம். இந்த வீடியோவை உங்கள் ஃப்ரெண்ட்ஸுக்கெல்லாமும் ஷேர் பண்ணுங்கள். இது ரொம்ப யூஸ்ஃபுல்லாக அவங்களுக்கு இருக்கும். ஸோ நம்ம வீடியோக்குள்ளே போகலாம். Important problems in application of integral. First question. Find the area of the region bounded by the curves x square plus y square is equal to 4, y is equal to root 3x and x-axis in the first quadrant. Solution given. X square plus y square is equal to 4. It is the circle, we know that. Y is equal to root 3x. It is a straight line equation. So we have solving both the equation. We get x is equal to plus or minus 1. So given x-axis in the first quadrant, நம்ம பாசிட்டிவ் வேல்யூவோட எக்ஸோட பாசிட்டிவ் வேல்யூவை எடுத்துக்கலாம். when x is equal to 1 y is equal to root 3. Therefore intersection point 1 comma root 3, 1 comma minus root 3. So first we have to draw the diagram. First x square plus y square is equal to 4. So this is in the form radius ங்கிறதுனால center at the origin and radius at 2. So 0 comma 2, 0 comma minus 2. Like that 2 comma 0 minus 2 comma 0, and that intersecting point also 1 comma root 3, we know that. Using this table we can draw the circle here. X square plus y square is equal to 4. Like that we have to draw the straight line. Y is equal to root 3x. When x is 0, y is 0, we have using values something. X is equal to 1, then y is equal to root 3. If you put x is equal to root 3, y is equal to 3. Mark the points in the diagram and start the straight line. This is the straight line. Y is equal to root 3x. So here this straight line y is equal to root 3x, x square plus y square is equal to 4 intersecting at C. That coordinate is equal to 1 comma root 3. So we want to get the required equation, area in the shaded region. Shaded region la area required என்ன OABCO. That is equal to area between OACO plus ABCA. So area between OACO is a straight line, and here 1 to 2 போகும்போது இது வந்து curve. So we using this y is equal to root 3x plus area between the curve x square plus y square is equal to 4. So area between the straight line வந்து 0 to 1 root 3x dx. We have to solve this integral of x square by 2. So put upper limit and lower limit. We get root 3 by 2. 1. That is area between the line and the x-axis. Then area between ABCA. So limit goes to 1 to 2 root of y dx. Here y is equal to x square plus y square is equal to 4. We get y square is equal to 4 minus x square. Therefore y is equal to root of 4 minus x square dx. We know that area between the curve is equal to integral y dx. So y is equal to here 4 minus x square root dx. So we know that here a is equal to 2. That is in the form root of a square minus x square dx. Root of a square minus x square dx integral is equal to x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. So substituting the values, we get in x by 2 root of 4 minus x square plus a square is equal to 4, 4 by 2 sine inverse of x by 2. Limit goes to 1 to 2. So using upper limit and lower limit, first we using 2, here 4 minus 4 is equal to 0. So first we get 0. 0 plus 2 sine inverse of 1 minus of lower limit, we have to prove that 1 by 2 root 3 plus sine inverse of 1 by 2. So sine inverse of 1 is equal to pi by 2. Here sine inverse of 1 by 2 is equal to pi by 3. So on solving, we get 2 pi by 3 square units. Therefore, required area 2 pi by 3 square units. This answer to, here we have to add 1 plus 1 plus 2. First area root 3 by 2 we have find out here. So second one is pi minus root 3 by 2 pi by 3. Adding 1 and 2 we get the answer. Required area is equal to 2 by 2 pi by 3 square units. Second one. Make a rough sketch of the region x comma y such that y is greater than or equal to 0 and less than or equal to x square plus 1, and y is greater than or equal to 0 and less than or equal to x plus 1, and x is greater than or equal to 0 and less than 2, and find the area of the region using the method of integration. Here, solution. So given y is equal to x square plus 1 is a second degree equation, we know that it is a curve, and then y is equal to x plus 1 is a straight line, then x is equal to 2 is a straight line. So given facts, we have to take at least 3 values. Draw the diagram. Here y is equal to x square plus 1. This straight line is y is equal to x plus 1. This straight line is x is equal to. Then we get the point of intersections. Here y is equal to x plus 1. Here y is equal to x plus 1. So comparing both sides, we get the values of x is equal to 0 and x is equal to 1. So using this one, x is equal to 0, y is equal to 1. X is equal to 1, y is equal to 2. So intersecting point are 0, 1 and 1, 2. Here P and Q are intersecting point. P 0, 1, Q 1, 2. So area between the curves and straight line is the shaded portion. Area of the shaded region O, P, Q, R, T, S, O is equal to. So we have starting here O, P, Q, R, T, S and ending here. So this is equal to area of the region O, S, Q, P, O, this portion, plus Area of the shaded region STRQS. So this is here 0 to 1 x square plus 1 dx plus here 1 to 2 x plus 1 dx. Integrating as usual, x square equal to x3 by 3 plus x dx using lower and upper limit as 0 to 1, and then here x square by 2 plus x using 1 comma 2. On solving, we get 23 by 6 square units. Here upper limit minus lower limit. Upper limit 1, lower limit 0 na everything becomes 0. Here upper limit 2 square 4 by 2 plus 2 minus of 1 by 2 plus 1. On solving, we get the values as 23 by 6. Question number 3. Make a rough sketch of the region x comma y such that y is greater than or equal to 0 and less than or equal to x square, y is greater than or equal to 0 and x is less than or equal to x, and x is less than or equal to 2. Solution. Given y is x square and y is equal to x and x is equal to 2. So first we have to find the point of intersection. Y is equal to x square and y is equal to x given. Using this value x square x, we get x is equal to 0 and x is equal to 1. When we put x is equal to 0, y is also 0. When x is equal to 1, y is also 1. Therefore, intersecting point are 0, 0, 1, 1. Draw the diagram using the datas, about datas. At least you have to take 3 values. Students, you have to take 3 values to draw a diagram. So see this diagram. Required area is equal to O, A, B, C, D, O. That is area OADO plus area between ABCD. ABCD A. ABCD A. Area OADO is a curve. Therefore, here x goes to 0 to 1. Here 1 to 2. X square dx plus 1 to 2 x dx. On integrating, we get x3 by 3. Using upper limit 1 to 0, we get 1 by 3. Here, integral x dx is equal to x square by 2. Using upper limit to lower limit to 1, we get the values 11 by 6 square units. Fourth question பார்க்கலாமா? Find the area enclosed by the parabola 4y is equal to 3x square and the line 2y is equal to 3x plus 12. So here also one parabola and a straight line. So solving both sides, first you have to find out the point of intersection in each sums. If two or more curves are intersected between them, first we have to find the point of intersections. So 4y is equal to 3 square, 2y is equal to 3x plus 2. So multiplying by 2 we get 4y is equal to 6x plus 2, 24. Equating both sides we get 3x square minus 6x minus 24 is equal to 0. On taking common 3 out, x square minus 2x minus 8 is equal to 0. On solving this get x is equal to 4 and x is equal to minus 2. When x is equal to 4, we get y is equal to 12. When x is equal to minus 2, we get y is equal to 3. Therefore, intersecting points are 4, 12 minus 2, 3. So, given point we have to draw the diagrams. See the diagrams. This is 4y is equal to 3x square circle, that is a parabolic curve. This straight line intersecting this line 2y is equal to 3x plus 12. So intersecting point here minus 2, 3, here 4, 12. Here we have to see one thing. Required area is this shaded in red. But we have to find the whole area and eliminate this shaded portion of blue. Then we get the required area AOBA. So area OBAO is equal to area CDBA, total area CDBA C minus area ODBO, this part, plus area OCAO, this part. So total area வந்து இந்த two areas நம்ம add பண்ணி subtraction பண்ணா we get the required area of shaded in red. Area CDBA is a straight line, so it goes to minus 2 to 4 total area. Here minus 2 x is equal to minus 2 to x is equal to plus 4. So 3x plus 12 by 2 dx minus 2 to 4 minus area ODBO plus area OACBO. It is a curve, part of the curve. So part of the curve in 3 by 4 x square dx minus 2 to 4. On integrating, we get 1 by 2 is taking as common, then 3x square by 2 plus 12x. Then we get using upper limit and lower limit of 4, minus 2. And then minus 3 by 4 x square dx. X square dx we know that x 3 by 3. Here upper limit is 4, lower limit is minus 2. So using these values we get required area is equal to 27 square units. Fifth question. Using integration, find the area of the region bounded by the curves y is equal to root x and x is equal to 2y plus 3 and x-axis in the first quadrant. Solution. Given y is equal to root x and another one is x is equal to 2y plus 3. So we have to solve these two equations. Squaring y is equal to root x, y square is equal to x. Here substituting x plus 2y plus 3, then we get y square minus 2y minus 3 is equal to 0. So on solving, y is equal to 3 and y is equal to minus 1. If we put y is equal to 3, then x is equal to 9. If we put y is equal to minus 1, x is equal to 1. Therefore, intersecting points are 9, 3 and 1, minus 1. So, if given y and all greater than 0, point of intersection we take 9, 3. Then as usual, we have to draw the diagram taking any 3 values for x and y. Here y is equal to root x, when x is equal to 0, y is equal to 0 and x is equal to 9, y is equal to 3. This point be intersecting point 1, minus 1 here. Here 2y plus 3 is equal to x, then y is equal to x minus 3 by 2. And taking any value as usual, we have to draw the straight line. Here 2y is equal to x minus 3, here this straight line. Area in the first quadrant. Here we have to take area is equal to integral x dy. So taking limits of y 0 to it goes to 3. So x dy, whereas x is equal to first case straight line 2y plus 3. Therefore 0 to 3 2y plus 3 dy and this expression y is equal to root x, here x is equal to y square. So 0 to 3 y square dy. So on solving it, 2y equal to y square by 2 3y, limit 3 to 0, here minus y 3 by 3 and 0 to 3. So we get answer 9 square units. Here we are taking area between the curve is equal to integral x dy. Sixth question. Using integration, find the area of the region x, y such that absolute value of x is greater than or equal to y and less than or equal to 4 minus x square root. So given here ஒரு curve and straight line. Modulus of x is equal to y. So modulus of x is equal to y implies x is equal to y as well as minus x also y. So we have to solve this equation. X square plus y square is equal to 4. It is a circle. It goes to 0 to 2 radius. This is in the form x square plus a square is equal to r square. Here r is equal to 2. So radius is equal to. So draw the circle. So everything is greater than y is greater than 0. Now we have to take upper part only. So area between OABCO is equivalent to 2 times of the area between OABO. So area between OABCO is lies and in between x is equal to 2 here. Here x is equal to minus 2. So area is equal to 2 into 0 to 2 root of 4 minus x square dx. Here 4 minus x square. This is in the form root of a square minus x square dx. Students, every time you have to write the formula, that is very important. Then x by 2 root of a square minus x square plus a square by 2 sin inverse of x by a. So applying this formula and using the limit 0 to 2, we get area is equal to 2 pi square units. Therefore required area 2 pi square units. Next question. Find the area of the region bounded by the ellipse. X square by 16 plus y square by 9 is equal to 1. So it is a circle only. So it is in the form x square by a square plus y square plus b square is equal to 1, where a is equal to plus or minus 14, b is equal to plus or minus 3. Draw the curve. Area of the ellipse is equal to 4 into this y dx, this part. O, A, B, O. So 4 into area O, A, B, O. So integral y dx, we use x square plus y square is equal to 1. Therefore we get y is equal to root of 9 by 16 into 16 minus x square dx. That is 3 by 4 into root of 16 minus x square dx. Already we have 4 into similar now. 4 now 3 times into 0 to 4, 16 minus x square. Here also this is in the form x square minus x square root of is equal to x by 2 root of a square minus x square plus a square by 2 sin inverse of x by a. Students, மறக்காதீங்க, எவ்ரி டைம் எந்த கொஸ்டின் போட்டாலும் சரி ஃபார்முலாவை எழுதணும். ஃபார்முலாவுக்கு they are giving 1 marks. So using the one, we get 3x by 2 into 16 minus x square, 16 by 2 in the sin inverse of x by 4. Limit is 4 to 0. So using this we get 12 pi. Answer is 12 pi square units. Question number 8. Find the area bounded by the line y is equal to 3x plus 2, the x-axis, and the coordinate x is equal to 1 and x is equal to minus 1. Given y is equal to 3x plus 2, it is a straight line. Here also both are a parallel lines. X is equal to 1. Solving, we get intersecting point 1, 5 minus 1, minus 1. Draw the table and plot the marks. So you get area below the x-axis and area above the x-axis. So area below the x-axis. So O A B O plus O C D O. Area below the x-axis. OABO plus area above the x-axis. OCDO. So required area is equal to minus 1 to minus 2 by 3. Minus 1 to minus 2 by 3 and minus 2 by 3 to plus 1. Plus 1. So curve is equal to 3x plus 2 is equal to dx. So we on solving 3x square by 2 plus 2x using upper limit minus 2 by 3 and lower limit minus 1. Like that, using upper limit 1 and lower limit minus 2 by 3, we get minus 1 by 6 plus 25 by 6. Here we have to understand here, this is the area, so we have to ignore the negative sign. So area always positive. Therefore, we are taking here 1 by 6. So here 25 by 6, 26 by 3, 13 by 3 square units. So area is equal to 13 by 3 square units. Ninth question. Find the area bounded by the curve y is equal to cos x between x is equal to 0 and x is equal to pi. This is a trigonometric problem. கொஞ்சம் கவனமாக போடலாம். Cos x. Cos x value வந்து we know that cos 0 1 but cos 90 0. So it is a cos 0 1 cos 90 0. So this is known as a decreasing function. So we have to start y is equal to cos x. So 0 pi by 2 pi 3 by 2 into 2 pi they are given. X is equal to 0 to 2 pi. So here we have to start a cos 0 1. One length pona a to b. Again pi by 2. Here pi c. Then d. Then 2 pi e. So a b c d e. So required area is equal to OABO plus BCDB plus DEFD. So here OB BAOக்கு 0 to pi by 2. Here pi by 2 to 3 pi by 2 and 3 pi by 2 to 2 pi. We know that cos x integral of cos x is equal to sin x. So using the limits properly. Sin pi by 2 is equal to 1. Here sin 3 pi by 2. Sin 3 pi by 2 is equal to sin 270. More than 90, we have to split into 180 plus or 180 minus. Here 270, here 180 plus 90. 180 na no change, sin 90. But 180 plus 90 lies in third quadrant. So we have put minus sign. So sin 3 pi by 2 is equal to minus 1. Sin 2 pi is equivalent to sin 0. Sin 0 is equal to 0. So using these values, we get 4 square units. Since area is always positive, we have to absolute value of minus 2 is always we have to take 2. Sketch the graph of y is equal to absolute value of x plus 3 and evaluate integral minus 6 to 0 absolute value of x plus 3 dx. Here key point, given y is equal to absolute value of x plus 3, then we have to write y is equal to x plus 3 if x is greater than or equal to minus 3. How x plus 3 is 0 is given, therefore x is equal to minus 3. So in positive, x is greater than or equal to minus 3, we have take x plus 3. If x is less than minus 3, we get y is equal to minus of x plus 3. So draw the curve when x is equal to greater than minus 3 and x is equal to less than minus 3. Here is x is greater than or equal to minus 3. This line is x is less than or equal to minus 3. So required area minus 6 to 0 and minus 6 to minus 3, minus 3 to 0. So here A, B, C, A and C, O, D, C. C, B, A, C plus area C, O, D, C. So limit minus 6 to plus 0 gives minus 6 to minus 3 if negative minus of x plus 3 and minus 3 to 0 x plus 3 dx. So on solving, x is equal to, we know that x squared by 2, 3x, upper limit minus 3 to lower limit minus 6, and in this case x plus 3 is x squared by 2 plus 3x, upper limit 0 and lower limit minus 3. Substituting values upper limit and lower limit, we get minus 9 is equal to 9 square units. Eleventh question. Find the area bounded by the curve y is equal to sin x between x is equal to 0 and x is equal to 2 pi. Here also this sum is similar to ninth question. There they are given cos x, here they are given sin x. So draw the graph 0 0 5 by 2 pi 3 by 2 2 pi like that. This is a sine curve. Y is equal to sin x. So required area is equal to 0 to pi sin x dx and pi to 2 pi. So both are same करतनाला 2 times from 0 to pi sin x dx. So sin pi is 0, sin 2 pi is 0. So one values if you are get O, A, B, O, that is equivalent to B, D, C, B. So 2 times of 0 to pi sin x. So sin integral of sin x is equal to minus cos x. So we get minus cos x, upper limit cos x. You know that cos pi cos 180 is equal to minus 1. Cos 180 next to second quadrant it is minus 1. Cos 0 is equal to 1. So substitution we get 4 square units. Therefore total area shaded area is equal to 4 square units.